Good morning, students. So today we are going to start with the next topic, that is electromagnetic waves. In the last class, we have completed current electricity. So today let us start the electromagnetic waves. So first, let us discuss some of the formulas and some of the properties and the characteristics which will come in this chapter. Okay. First is what? That is electromagnetic waves. So what do you mean by electromagnetic waves? That we need to understand here first. So here, as the term indicates, as the term is saying, it is electromagnetic waves, right? So first you should know what do you mean by waves. So already now waves matte oscillation chapter alli now discuss madidvi. What do you mean by waves here? Waves is nothing but when the disturbance is created in the medium, when there is a disturbance in the medium, the waves are created. When the disturbance is created, the waves are created in the medium. So what is electromagnetic wave? This electromagnetic, I can split it into two parts. It becomes electro and the magnetic. So electromagnetic means here the electric field and also the magnetic field will be there. So the electric field and both the magnetic field will be there. That is called as what? Electromagnetic wave. So how we can define this electromagnetic wave? That is that with respect to time, the electric field and the magnetic field are varying. The electric field and the magnetic field are varying. With respect to what? With respect to time, it is varying. And whatever this electric and the magnetic fields are there, they are perpendicular to each other. They are varying perpendicular to each other. Like this we can represent it. Okay. So this is electric and the magnetic field. So what are the examples of electric field here? Electromagnetic waves. The electromagnetic waves, the examples we have, that is visible light. Then we have the X-rays. Then we have UV rays. These are the examples for the electromagnetic waves. So electromagnetic waves are the waves which is having both electric and magnetic field, which is varying with respect to time. Okay. Then next, they are perpendicular to each other. These are the examples here. Next, we are going to see what are the source of this electromagnetic waves. So the next point is, what is the source of electromagnetic wave? The source of electromagnetic wave is oscillating charged particles. So here the oscillating charged particle is the source of this electromagnetic wave. Next, we have what is the nature of this electromagnetic wave? The nature of the electromagnetic wave is it is transverse in nature. It is transverse in nature. So we have two types of waves, that is longitudinal wave and the transverse wave. These electromagnetic waves are transverse in nature. They are transverse in nature. Okay. Then next, some of the characteristics or some of the properties we will discuss now. Here, the electromagnetic waves are traveling always in a straight line. The first property is the electromagnetic waves are traveling in a straight line. Then the second property is they travel with a velocity of 3 into 10 to the power 8 meter per second. These electromagnetic waves travel with a speed of 3 into 10 to 8 meter per second. That too where? In the free space. It is in the free space. Okay. So in the vacuum, this speed will vary. In the vacuum, this speed will vary. Next point is, here whatever these electromagnetic waves are there, they will carry energy as well as momentum. They will carry energy as well as momentum. Okay. These are some of the important properties of your electromagnetic waves. They travel in a straight line in a homogeneous medium. They travel with a speed of 3 into 10 to 8 meter per second in the free space. Then they carry energy and momentum and they are transverse in nature. So we can write one more point here. The speed of the electromagnetic wave is given by C is equal to 1 divided by under root of mu naught into epsilon naught. where mu naught is called as permeability, epsilon naught is called as permittivity. This is where this is in the free space. Okay. So in the medium, the same expression can be written as the velocity of light is equal to, sorry, speed, the velocity of this electromagnetic wave is equal to under root of mu into, sorry, epsilon, only epsilon, not epsilon naught. Okay. This is in the medium. Yes. So here, this is about the electromagnetic waves definition. The source of electromagnetic wave is oscillating charged particles. Then these are the properties of this electromagnetic wave. Then let us go for the next point. That is, here the electromagnetic spectrum we will study later. The next concept is electromagnetic spectrum. So what is electromagnetic spectrum here? Here, whatever the electromagnetic waves are there, the electromagnetic waves are arranged. They are arranged in a one particular manner or the single chart, that is called as what? Electromagnetic spectrum. So the electromagnetic spectrum is what? The electromagnetic waves are arranged in particular order or the manner here. This is called as electromagnetic spectrum. So we have the example for the electromagnetic spectrum. Yes, so the examples, we have 7 waves or the 7 electromagnetic spectrum we can say. That is, we have X-rays, then we have gamma rays, UV rays, that is ultraviolet UV rays, IR rays, that is infrared rays, then we have microwaves, then next we have radio waves, then we have visible light, So these are what? These are the 7 electromagnetic spectrum examples. Okay. So in this chapter, we will study what are the different properties of these 7 electromagnetic spectrum and what are the uses of these 7 electromagnetic spectrum that we will study in this lesson. Okay. So now what we will do, we will go with the questions. So there, whatever the explanation is required for the particular waves, that we will discuss. Okay. So if based on that, if questions are there, we will see the questions. Otherwise, after seeing the questions, if we require, we can see all the properties as well as the uses of these all spectrum here. Okay. So let us go for the questions now. So our first question is, this is the first question. What is the question? That is, what is the ratio of the speed of infrared and ultraviolet rays in a vacuum? So what they're asking here, so in the vacuum, what is the ratio of speed for the infrared and ultraviolet rays? Yes. Is it 1:5, 2:1, 1, or it is 0? Other students, see, question ಏನಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು ಇಲ್ಲಿ, they are asking you the ratio of speed. So the ratio of speed, that is for the infrared rays and for the ultraviolet rays and for the ultraviolet UV rays. Okay, so they are asking you the ratio of the speed here. Just now while explaining you the properties, ನಾನು ಏನಂತ ಹೇಳಿದೆ ನಿಮಗೆ, the speed of the wave in the vacuum, it is same. Okay, if it is in the medium, it will vary, but it is in the vacuum, it is same. So as the value is same, therefore we will get it as what? 1:1. That is option C is correct here. Option C correct agate. So Lohit has given the right answer. Lohit is right. The next, yes, Shilpa, Viresh. Yes, option C is correct here. I hope. Okay. Okay, so our next question is, what is the velocity of electromagnetic wave in the free space? So the velocity, again in the synopsis, we have completed this one. Yes, so here the options, there is a slight mistake in this one, that is, okay, what it is, that is option A is what? Option A is under root of mu naught epsilon naught. Option B is 1 divided by, ಇದು 1 divided by ಆಯ್ತಾ. So this is 1 divided by under root of mu naught epsilon naught, and option C is 1 divided by mu naught epsilon naught. Option C is mu naught epsilon naught. So again in the synopsis we have completed this one, that is option B. Option B is correct here, 1 divided by under root of mu naught epsilon naught. Okay, so that is option B. Then the next question. So who all are giving the answer? Let us see. It is option B. Purvi, Shilpa, yes. Then the next question. Which basic oscillator circuit is used these days to produce electromagnetic waves? So what I told you, that is electromagnetic waves we can generate it. ಯಾವ ತರ electromagnetic waves ಮಾಡಬಹುದು? By using the charged oscillating particles. ಹೌದಾ? ಅವ್ರು ಏನ್ ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ? That is circuit they are asking you. Basic circuit to generate or to produce electromagnetic waves. So here the options are LC oscillator circuit, LC oscillator circuit, inductive circuit, capacitive circuit. From the and Abhishek is saying yes, this A is right, that is LC oscillators. So now we are using LC oscillators to produce the what we can say, that is electromagnetic waves. So students, here the answer is LC oscillator, right? Then the next question, yes, Harshita, Kusum. Then the next question, is the ratio of frequencies of UV rays and IR rays glass more than, less than or equal to 1? So that is UV rays and the IR rays. UV rays and the IR rays here. What they are asking you? They are asking you, so the rays in the glass more than, less than or equal to 1 they are asking. Here the options are insufficient data, then the equal to 1, less than 1, more than 1. So what do you feel? Okay. The ratio of frequencies of UV and IR in the glass, it is always greater than 1. Here option D is correct, students. So it is not an insufficient data. Option D, that is, it is more than 1. The ratio is more than 1. Okay. So if it is in the medium, then it is more than 1. Suppose if it is in the, then it is equal to 1. Okay. Then the next question. For which frequency of light the human eye is most sensitive? So human eye is most sensitive for. Our eye is able to see only the visible light. Our eye is able to see only the visible light here. What they are asking you? They are asking you, our eye is sensitive, most sensitive frequency. So here Viresh Soundarya is saying A is 55.405 into 10 to the power 14, 95.405 into 10 to 14, 5.405 into 10 to 14, for 79.405 into 10 to 14 hertz. See here, students, our eye is sensitive for option C, that is 5.405 into 10 to the power 14 hertz. That is option C is correct here. Option C correct agate aita. Then next option C is right. So here is our next question. Yes. Microwaves cannot be used for long distance transmission of signals. So the statement is true or false? Yes. Here the microwaves can be used for the here option B, that is it is false because we can use the microwaves for the long distance transmission. So here option B is there. That is we can use it, therefore it is a false statement. It is a false statement, right? Then the next question. Then the next question is the wavelength of electromagnetic radiation is doubled. What will happen to energy photons? So the wavelength of electromagnetic radiation is doubled here. What will happen to the energy? So we know that so yes, that is Shilpa, you are right. That is option B is correct. So see here students, that is here how we write it, that is given by energy E is equal to H nu. Energy is equal to H nu. So here it is wavelength relation. Therefore, it is Hc divided by lambda. What they are saying here, the wavelength of the electromagnetic wave is doubled. Doubled in the sense it is increasing. Therefore, what happens to your energy? Energy and wavelength are inversely proportional. So when your energy is becoming twice, your energy is reducing by half. Okay, that is option B is correct here. I hope the concept is clear to you. Let us see the next question. What is the time period of visible light for which human eye is most sensitive? It is 1.85 into 10 to the power 15 seconds. 1.85 into 10 raised to minus 15 second, 3 into 10 raised to 8 second, 5 into 10 raised to 16 second. So here it is time period. Okay, now Hindi question now in nodidvi, that is the frequency. So here it is time period, that is for this question, it is option B is right. It is option B, 1.85 into 10 to the power minus 15. Okay, so if you want the proof how we can do this, ಇದನ್ನ ಯಾವ ತರ ಮಾಡಬಹುದು ಅಂತ ಅಂದ್ರೆ lambda is equal to, so wavelength value is constant, that is 5600 angstrom, right? The relation is what, that is time period is equal to the reciprocal of frequency. It is the reciprocal of frequency. So therefore it is reciprocal of frequency in the sense lambda divided by c. Our lambda value is 5600 into 10 raised to minus 10, right? Divided by velocity of light in the vacuum, this into 10 raised to 8. So ನೀವು ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಆಪ್ಷನ್ ಬಿ ಬರುತ್ತೆ. ಓಕೆ, then the next question, on what basis is the classification of electromagnetic waves done? Electromagnetic spectrum, electric field, magnetic field, propagation constant. Yes, now everybody should answer this one. So electromagnetic waves, on what basis the classifications are done here? Yes, Purvi, Chaitra, option A is correct, students. Lakshmi, electromagnetic. Electromagnetic. The next question, which among the following has a frequency range of 500 kilohertz to 1000 megahertz? So ನಾನು ನಿಮಗೆ ಮತ್ತೆ ಹೇಳಿದ್ದೆ that we will questions based on the properties of the electromagnetic spectrum. So 7 electromagnetic spectrums I do ಅದರಲ್ಲಿ ಏನು ಕೇಳ್ತಿದ್ದಾರೆ, ಯಾವ 5000 kilohertz ಇಂದ 1000 megahertz ಇರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ, ಹೌದಾ? So that is microwaves, infrared waves, radio waves, and the gamma rays here. So here what students are saying, that is option, that is radio waves. Okay, so option C is correct, that is radio waves. Option C is right. It is radio waves. Okay, then the next question. So here is our next question. The question is, what is the full form of UHF? What is the full form of UHF? Yes, under heavy frequency, ultra high frequency, ultra heavy frequency, under high frequency. Which one is right? B or C? Yes, correct it is. So option B is correct, that is ultra high frequency. It is ultra high frequency. Next question, microwaves are produced by klystron. Microwaves are produced by klystron. Whether it is true or false? Yes. Yes, Abhishek. It is true. Aita idu true agatte. That is the microwaves are produced by the clistromere. That is correct option. Option A is right. Then the next question is, which among the following is an application of microwaves? So here we need to see the uses or the applications of all the spectrums here. In that they have given one, that is application of microwaves. They are used in the solar cells, ovens, radiotherapy, burglar alarms. Yes, 100%. That is Hema, Purvi, Lakshmi, Amruta. Yes, correct everyone. That is ovens. It is used in the ovens here. Then our next question. Identify the electromagnetic is also known as heat waves. So here you need to answer which are also known as heat waves. Gamma rays, gamma waves, radio waves, gamma waves, X-rays, and the infrared waves. Yes. No. It is option D, that is infrared waves. Students, it is option D, infrared waves. Infrared waves are also known as heat waves. No, it is option D, infrared rays. Pick out the electromagnetic wave which is highly harmful to the humans. Radio waves, microwaves, ultraviolet, infrared waves. Harmful for the human body. Which one? Yes, Purvi, you are right. So students, ಇಲ್ಲಿ infrared UV rays ಏನಿರುತ್ತಲ್ಲ, that is very harmful for the human skin here. So UV rays ಇಂದ ನಮ್ಗೆ ಏನಾಗುತ್ತೆ, skin diseases ಬರುತ್ತೆ. So UV rays are the very harmful for the humans. Then the next question is, that is, Stephen is thinking of going to the hospital for checking whether he has, that is TB. So here it is whether he is having the TB, since he believes that he may have some early symptoms of the disease. His friend suggests he to do an X-ray checkup, clear up the confusion. So what Stephen is thinking, that is he is suffering from the TB. What his friend will suggest him, go for the X-ray checkup for to clear your confusion. So what they are asking you now, rain ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ confusion ಇದೆ ಅಥವಾ friend ಏನು suggest ಮಾಡ್ತಾ ಇದ್ದಾನೆ, that is correct or no, whether it's true or no. Yes. So with the X-ray checkup, yes, it is true. How the students X-ray checkup, what he can take the photograph of his lungs. So whatever the lungs are there, how it is looking, he can understand by his X-ray photograph. So therefore his X-ray photograph will give him the clear idea whether he is suffering from the TB or no. That is option A is correct. Right? Then the next question. Monica wanted to take photographs of a mountain, but since the surrounding is filled with smoke, so the surrounding is filled with the smoke here, she is not able to take a good photos. Which one of the following electromagnetic waves can be used in this situation to help Monica? So that is what Monica can do here. She can use the X-rays, gamma rays, ultraviolet rays, infrared waves. Yes. Gamma rays, X-rays are the answer from the students. Yes, students, it is, she should use infrared waves. Here she should use infrared waves so that she can get the clear picture. Here what is happening, that is the surrounding is filled with the smoke. So when she will use infrared waves here, that time here whatever the picture is there, you will get the zoom cleared picture. You will get the cleared picture. then the next question is, which is the frequency range of gamma rays from the following? So ನೀವು ಕಲ್ತಿದ್ದೀರಾ ಇದನ್ನ ಆಲ್ರೆಡಿ, ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ ನೀವು ಹೇಳ್ಬೋದು, ಇಲ್ಲ ಅಂತಂದ್ರೆ once again I'll tell you all the properties and the uses of all the given 7 spectrums. Anybody knows? It is C. Option C is right. That is 3 into 10 to the power 18 to 5 into 10 to the power 22. Option C. Aita. So electromagnetic waves, it is one of the very simple lesson. Hardly you will get 1 marks. Yeah, tappi avagladru 2 marks barutte, but maximum we will get only 1 mark question from this chapter. Yes. Then the next question is, a radio can tune to any station in the frequency range from 2.5 megahertz to 15 megahertz. So frequency range yesterday 2.5 megahertz in the 15 megahertz varigide. What is the corresponding wavelength band? So egaste na one question alli nodidvi how you can give the relation between frequency and the wavelength here. Adanna use ಮಾಡಿ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, ಗೊತ್ತಿದ್ರೆ ಮಾಡಿ, ಇಲ್ಲ ಅಂದ್ರೆ ನಾನು ಇಲ್ಲಿ ತೋರಿಸ್ಕೊಡ್ತೀನಿ ಆಯ್ತಾ. So I think question number 8 or 7 ಅಲ್ಲಿ ನಾವು ಮಾಡಿದ್ವಿ ನೋಡಿ, ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ವಿ. So here what you require, that is what is the corresponding lambda. So lambda is equal to it is C divided by F. C is the velocity of light in the vacuum. F is the frequency. So students, will you calculate and tell the answer? Yes. C. Yes, correct answer. ಇಲ್ಲಿ ನೋಡಿ, C value is 3 and the F value is 2.5 hertz and 15 megahertz. We can substitute, we can calculate the value, we will get option C is the correct answer. Option C is the correct answer. Next question. The speed of microwaves, infrared waves and ultra waves are Vm, Vi and Vu respectively. Identify the correct combination showing the different waves in vacuum. Very simple answer. Yes. So question, the double inverted point is, that is, it is in the vacuum. So already in the first or second question ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದೆ, vacuum ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಲ್ಲದರದ್ದು ಸ್ಪೀಡ್ ಈಕ್ವಲ್ ಇರುತ್ತೆ. So which relation is true here? ಯಾವ್ದು relation true ಆಗುತ್ತೆ ಹೇಳಿ? Yes, it is option B. Option B is correct here. Then our next question is, so the next question as well as the last question. Electromagnetic radiation has an energy of 15 kilovolt. Then this radiation belongs to which region of electromagnetic waves? X-rays, infrared rays, gamma rays and the UV rays here. Infrared baratta, X-rays baratta? Yes. So if it is 15 kilovolt, it is X-rays. It will lie in the X-rays here. So option A is correct. Option A is correct. Okay. So as I told you, so these are the simple questions. So nimge you will note nimge maximum 90% nimge ಏನು ಬರುತ್ತೆ, theory questions ಬರುತ್ತೆ ಇಲ್ಲಿ, ಹೌದಾ? So ನೀವು ಈ lesson ಅದು theory ಸ್ವಲ್ಪ clear ಆಗಿ ಓದ್ಕೊಂಡ್ರೆ ಅಷ್ಟು ಸಾಕಾಗುತ್ತೆ. So already we have seen how the questions you are getting here. Yes, so in the previous years also almost nimge properties of the spectrum and the uses of the spectrum ಮೇಲೆ questions ಹೇಳಿದ್ದಾರೆ. So already I told you how many spectrums we have. We have total 7 spectrums. Howda? So at least you need to remember the uses of all spectrum here. Okay. So gamma rays use ಮಾಡಬಹುದು. The gamma rays can be used where it can be used. Gamma rays can be used in the treatment of the cancer, Then gamma rays are used in the skin diseases. Then gamma rays are used to sterilize the surgical instruments. Okay. They are used in the gamma ray microscope. So, now gamma ray uses an TV. Then similarly, the X-rays uses here. The X-rays where all we can use it. So, X-ray is used to detect the unknown body, the unknown body in the unknown body and the foreign bodies in the human body that we can detect. For example, fracture X-ray we will take. So X-rays are used there. Then the X-ray is used to treat the brain tumor. Brain tumor treat ಮಾಡ್ತಾರೆ, skin disease ಅನ್ನ treat ಮಾಡ್ತಾರೆ, cancer ಅನ್ನ treat ಮಾಡ್ತಾರೆ. They are also used to test the quality of the welding in industry, and they are used in the crystal structure analysis. So here they are used in the crystal structures. This is about the X-rays. Then about your UV rays. So anybody knows UV rays ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಯಾರಾದರೂ ಹೇಳ್ಬೋದಾ? So you tell me where the UV rays are used, then I'll tell you. Some other questions which is asked in the previous years of the exams. Yes, in the signals to detect, yes. Electrophoresis, yes, very good. Yes, students, your answer is right. To preserve the food, very good. Okay, so welding metals, correct. So now I'll give you some questions which is asked in the previous years. Here we have one question like, the question is, that is a resistance is given as 100 ohm. The resistance is given as 100 ohm, and the capacitor of 100 ohm reactance. 100 ohm reactance capacitance in the sense, ನೀವೇನಾದ್ರೂ alternating current chapter ಅನ್ನ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. That is XC value is given as 100 ohm. They are connected in series across the potential difference of 220 volt. Across the potential difference of 220 volt. Then when the capacitor is 50% charged, when the capacitor is 50% charged, the peak value of the displacement current, the peak value of the displacement current, ID value they are asking here. The options are 2.2 ampere, then 11 ampere, 4.4 ampere, then 11 root 2 ampere. ನೋಡಿ ಈ ಕ್ವೆಶ್ಚನ್ ಅನ್ನ ನೀಟ್ 2016 ಅಲ್ಲಿನೂ ಕೇಳಿದ್ದಾರೆ, ಮತ್ತೆ ಈ ಕ್ವೆಶ್ಚನ್ ಅನ್ನ ಕರ್ನಾಟಕ ಸಿಇಟಿ ಅಲ್ಲಿ ಕೂಡ ಕೇಳಿದ್ದಾರೆ. So what they are asking you, displacement current ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಅವರು ನಿಮಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, resistance ಕೊಟ್ಟಿದ್ದಾರೆ, XC value ಕೊಟ್ಟಿದ್ದಾರೆ, and voltage value is given. So how to calculate the displacement current? ಆಲ್ರೆಡಿ ಕೊಟ್ಟಿರೋ ಡಾಟಾನ ನಾನು ಬರ್ದಿದ್ದೀನಿ. ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಇಲ್ಲಿ, ಫಸ್ಟ್ ಇಂಪೆಡೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. So the impedance is given by under root of R square plus XC square. So R square here, R square is nothing but 100 square. It is nothing but 100 whole raised to square plus XC. Again it is 100. Yes. So this, if I simplify, this will be 100 root 2. It will be 100 root 2. Now the displacement current is given by, it is the potential or the EMF upon the impedance. So what is the potential? They have given it as 220. It is given as 220. Yes. Then divided by, it is 100 root 2. It is 100 root 2. So here this potential is given as 220 into root 2. It is 220 into root 2. So what is the answer here, students? What is the displacement current value? Options nanil bardidini nodi. 2.2, 11, 4.4, 11, root 2. Which option is right? Yes, yes, Tarun, you are right. That is option A is correct. Other students, I hope everybody is getting the answer. Yes, Soundarya, correct. Okay. Then one more question we will see. Again, the previous question, this is asked in 2022. It is asked in 2022, means last year. Here the question is, when light propagates through a material medium, the relative permittivity is epsilon r. The relative permittivity is epsilon r and the relative permeability is mu r. The velocity of light v is given by, So the options are v is equal to c, then v is equal to 1 upon epsilon r, then v is equal to under root of epsilon r divided by mu r, then v is equal to option D, v is equal to c divided by under root of epsilon r into mu r. Yes. So what they are asking you, the velocity is given by. ಹೌದಾ, ನೀವು ಆಲ್ರೆಡಿ ನಿಮಗೆ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಗೊತ್ತಿದೆ. That is, in the vacuum, the velocity is given by 1 divided by under root of mu naught epsilon naught. Yes. So for any medium, the velocity is given by what? That is given by 1 divided by this mu naught. I'll take it in terms of what? That is relative permeability. Andre nanu idanna mu naught mu r and epsilon naught epsilon r anta tagondini. Aita? Now what I can do, I can split this one. I can split it and I can write it as the under root of mu naught epsilon naught and under root of mu r epsilon r. Okay. So therefore, this is nothing but, so according to equation 1 divided by mu naught epsilon naught is nothing but c divided by, it is under root of mu r epsilon r, that is v is equal to. So option D is correct. Option D is correct. Option D. Question I'll repeat. So Tarun, the question is what? They are saying that when a light propagates through a medium, the relative permeability is epsilon r and the relative permeability is mu r. The velocity v is given by. Only that much is given in the question. Howda? Velocity v edradna baratte anta. The velocity v is given by. So according to the properties of the electromagnetic wave, c is equal to 1 upon under root of epsilon naught mu naught. So ನಾನು ಇಲ್ಲಿ relative permittivity ಅನ್ನು substitute ಮಾಡಿ simplify ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Okay. So option A ಬರಲ್ಲ. Option option D is correct. I hope the solution is clear to everyone. Yes. Last one question. So again, this is a previous year question, 2018 question. ನಾನು ಇಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. So the one question is, an EM wave propagates in a medium with a velocity. So the EM wave is propagating with a velocity v is equal to v into I cap. The instantaneous oscillating electric field wave is along y-axis. So I'll repeat. The velocity is given as v is equal to v into I cap. Then the direction of oscillating magnetic field of the EM wave is along. So v is given by this equation. Then the electric field is along the y-axis. They are asking you what is the direction of magnetic field. Okay, so here the options are given as minus z direction. Option B is plus z direction. Then option C is minus y direction. Option D is, it is minus x direction. The electric field is along plus x plus y direction. I hope the question is given. The velocity is given by v is equal to v into I cap. Then the electric field is along plus y axis. What is the direction of the magnetic field? These are the options which they have given. So let us see the solution here. We know that is V is equal to E cross B. We know that V is equal to E cross B. Yes. So what is the given equation? So before going to write the given equation, it can be also written in terms of unit vector. V I cap is equal to E into J cap plus, into B. Yes. So here E is equal to what we are getting? E is equal to E J cap we are getting. E is equal to E J cap we are getting. Therefore, B is equal to B into K cap. B into K cap. Therefore, K cap is along which direction? So, if you see the Cartesian coordinates, it is X, Y, Z. Along X axis, it is I, unit vector I. Along Y axis, it is unit vector J. Along Z axis, it is unit vector K. So, for your magnetic field, what is the unit vector? It is K. Therefore, it is along the plus Z direction. The plus Z direction. Okay. So, question is very simple here, Tarun. That is the velocity is given as V is equal to V I cap and the question ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರಲ್ಲಿ electric field plus y axis ಅಲ್ಲಿ ಇದೆ. What is the direction of the magnetic field? ಅಷ್ಟೇ ಕೇಳಿದ್ದಾರೆ ಅವರು. ಹೌದಾ? So ನಮಗೆ ಇದು equation ಗೊತ್ತಿದೆ. V is equal to E cross B ಅಂತ. So therefore we are simplifying it and we will get that the magnetic field is along plus Z axis. Okay, students, I hope the electromagnetic waves, the lesson and the concepts are clear to you. So very simple questions we will get here, practice it. So in the next class, we will continue. Thank you.